Welcome everyone, and thank you for joining us today. Today's webinar is presented by Sports Turf Managers Association. Leading up to STMA's annual conference, we will be hosting various webinars that preview conference education sessions. Our featured speaker today is Dr. Adam Tomes, Assistant Professor at Iowa State University. He will be presenting a preview of his conference education session, Understanding Plant and Soil Interactions. Attendees will be muted during the presentation. If you have any questions, please use the Q&A feature. Please type in your questions and Dr. Tomes will answer them during the presentation. Thank you for joining us today. You can go ahead and get started.
All right, thank you, Kristen, and I appreciate all of you for your attendance today as we give a little bit of a introduction and lead up to the exciting face-to-face conference that we're going to have this year in January. And so this is a presentation that I'm going to do with Dr. Nick Christians, also from Iowa State, on Tuesday at the conference. And because of the short amount of time today, I'm going to just go ahead and present the information for myself and Nick, but he wanted to let you all know that he will be at the conference as well. And so he'll be presenting some of this as well. So let's go ahead and get started right away and discuss some of the basics of what we're going to cover. And so obviously, anytime we talk about plant soil interactions, we have to talk about, what's necessary for plant growth and what drives plant growth. And that's elements. There's 17 essential elements for plant growth, as most people know. I know on this webinar today, we have all different levels of expertise. And so we see everything from, those that have a great understanding of how plants grow to those that are maybe just getting started or interested in it. And so our seminar at the conference will kind of try to meet in the middle and try to cover a little bit of everything here. But these 17 essential elements are really what makes plants grow and what's essential for sustaining productive athletic fields. And these nutrients are needed in two different amounts. And so there's macronutrients, which are needed in larger amounts. And those, are very familiar. Everyone's used to those, hearing about those. And then micronutrients. And while they're needed in less amounts, they're not any less essential or less important. And so missing a micronutrient can really slow down the plant growth and really kind of limit your performance of your athletic field. And so it's very important to make sure you have a good eye on your micronutrients as well. So these 17 essential elements, the plant gets 3 of these elements from the air, and those would be carbon, hydrogen, and oxygen. They also can, pick some of that up from the soil as well. But the rest of the elements are what's essential for sustaining plant growth, and you have to provide those. One of the elements we won't talk much about today that we'll talk about in great detail in the seminar is nitrogen. Obviously, nitrogen is something that you don't, realize your use rate from soil testing. That's all tissue testing driven. And so that's something that you'll want to look into and see as a part of our full seminar. Today, we're going to talk mostly about soil testing and the nutrients, as well as, tissue testing for some of the micronutrients and some of the results there. So when we talk about agriculture and plant growth, typically what we see is a graph like this, and everyone's probably familiar with this. And so you've got the standard yield curve, and that's the more increasing elements, which is on the x-axis. The greater those, the greater the yield, which is on the y-axis. Obviously, with turf grass, yield is based in clippings or perhaps increasing density, things like that. But we realize from this graph that at some point in time, we can only apply so many elements, and then we kind of level off and limit our yield or our productivity. And so it's at that point that we're starting to waste money by applying nutrients that are unnecessary. In some cases, we can overapply nutrients and cause toxicities, issues like that. And so those are all things that we have to kind of watch out for and be careful with when we apply nutrients. And then the last thing that we don't want to do is have applying nutrients that end up moving offsite and cause environmental problems. So what do we do to make sure that we're not overapplying nutrients? Making sure our plant-soil interactions are at optimal conditions. First and foremost, we always say start with the soil test. Soil tests can be very useful for twofold. One, to detect differences or issues that we're having with our plant nutritional program. But then also we can use the results from the soil test or tissue test in some cases to show our administrators or those of us that are in charge, or those that are in charge of the budgets, that we need this money for fertility to improve our turf grass growth. And so when we look at soil testing, we've got the SLAN method, which is the sufficiency level of available nutrients. And the SLAN method is the oldest. Interpretation varies with crop, soil, climate. It's often used by university labs, public labs, and there's the most scientific research that stands around the SLAN method. We've also got the BCSR. And the BCSR method is based on an ideal ratio of cations to exchange sites. Newer labs oftentimes use these. One of the worries that we have with this is that oftentimes this basic cation saturation ratio overestimates. And so we don't know what the overestimation always is on turf, but it's typically an overestimation. And so we have issues with that. The last one that you hear a lot about nowadays is the MLSN, or the minimum level for sustainable nutrition. And this sets the minimum required for optimal turf growth. And this is the baseline of soil nutrition. And that baseline, basically, they just tell you to keep your nutrient levels above this. It gives the minimum values, not a range. It tells you how much to apply and incorporates turf growth potential in. So, you know, the MLSN is a newer method, less literature out there on it. But again, a lot of people in turf are starting to use that to base their nutrient applications on that. And it's supposed to be a cost savings, things like that. So the usefulness of a soil test really depends on proper interpretation. And that's the big thing there for us. How useful is that information you're gathering depends on how well you can read it. And so what this seminar typically covers is the fact that it goes through and tells you line by line how to read it, and then how to turn around and use that as justification to increase your fertility budget to make sure you're getting the most for your money and hopefully keeping that budget line where you need it. So when you get a soil test, the first 3 lines are filled with very useful information. The first line typically is your CEC of the soil, or your cation exchange sites. And this tells you how much nutrition you can apply at one time, really. It's lower CEC soils like sand-based athletic fields. Those are going to be soils that are going to have to be spoon-fed or carefully applied, little bits of nutrition at each time. pH is also in those first 3 lines. pH, again, can give you an idea of when nutrients are available. And as the pH moves up and down the scale, certain nutrients are no longer available. And we, of course, show that traditional table that everyone's used to and talk about the movement of pH. Finally, there's buffer pH, depending on what your pH level is, that's presented as well. And buffer pH kind of gives you an idea of how hard it is to move your pH scale, depending on where you are. So again, pH, very important. Grasses like slightly acidic soil. One of the things that I a lot of times run into as being an extension agent is people that don't understand pH always say, well, I need to lime my turf every year. Well, that's not necessarily the case if you're already dealing with a basic soil. And so that can be problematic, and you can actually cause more problems for yourself if you're continuing to try to raise your pH when it doesn't need to be raised. So let's jump right in and use the remaining time to kind of quickly walk through some of these nutrients to give you an idea of, you know, what we're going to talk about in detail. And so we've got phosphorus here. I've got a table up here. If you were to use the Bray P1 extraction of what levels you should have for your nutrients in your soil, and that's kind of given there. Why is phosphorus important? Again, it's very important in energy transfer, genetic material. Grasses are very efficient users of peat. You can see it really doesn't take a lot of phosphorus to keep grass in the healthy and adequate range. Because of the fact that phosphorus is so important with genetic material and energy transfer, it's very important to have phosphorus available during establishment. Potassium is another one that we talk about. Potassium is kind of a mystery element. It's not a true part of the biochemical process in plants, but it acts as a cofactor. And so it's, you know, obviously part of the stomatal control for stresses and thought of as a stress element. Again, potassium is available in higher quantities. One of the unique things about potassium is that it can be luxury consumed by the grass plant. So what do we talk about here? Again, we bring back up this graph with luxury consumption. The higher levels of potassium in the soil equals a greater yield. But as it goes higher and higher, it's not really a yield, it's more of a stress type guard. And so we can see here, higher levels of potassium in the tissue, perhaps increase to better stress guard. Some research at Rutgers has showed that deficiencies in potassium actually lowered the tolerance of annual bluegrass with ice cover crown hydration. These deficiencies lowered the freeze tolerance by 5 degrees Fahrenheit. But what they did find in their research as well is that going above the adequate range did not help with the survival, it did not increase. So kind of the take-home message here, well, turf can help with stress results, with potassium applications. We don't really know how much luxury consumption really improves the stress tolerance completely. So we also talked about a few other of the macro elements, obviously calcium. I've presented here what it should be at the tissue test levels. Again, if it's deficient, you're going to see younger leaves turn reddish brown from calcium, and then it fades to red. Calcium deficiencies oftentimes show up in low pH conditions, and liming oftentimes solves this problem. Calcium is very important, cell wall formation, cell division, many processes there. So it is important to have proper calcium on board in your plant. We also talk about magnesium as macro element, of course. Again, we've got, if it's less than 0.15% of the tissue test, then obviously it's deficient. And soil tests, it's going to vary with the CEC levels. Magnesium, with a Malic 1 is 30 to 60 parts per million. A Malic 2, depending on how they, pulled that out or tested it, 70 to 140 parts per million. And these are with low CEC soils. A higher CEC soil, you can pretty much double the numbers from previous research. Again, magnesium is very important with the chlorophyll process. It's at the center of that. Low pH and low CEC type soils, you oftentimes see magnesium deficiencies. So if you're dealing with that, start to be careful watching for magnesium deficiencies. We move on to sulfur. Again, sulfur is one that we don't oftentimes see an issue with. Typically, if you have a sulfur deficiency, you're going to see slow growth, yellowing of younger leaves. Why is sulfur deficiency so rare? Well, one part, it's not needed in very high amounts in the tissue, but also it's fairly rare in the US because of the high sulfur in coal and that's been used for years. So in the Midwest, they estimate that between 12 and 15 pounds of sulfur per year are applied through rainfall to each acre in the Midwest. And so as we move away from coal-fired power plants, we might start to see more sulfur deficiencies as we move forward. We also see iron deficiencies, and that could be an issue there as well. Soil tests are really inaccurate for iron deficiencies. Very small amounts can be applied to tissue, and again, it doesn't move, and so iron, is right there. It gives you that dark coloring. It can be a cofactor of chlorophyll formation and can be good there. It's the most common of all micronutrient deficiencies. One of the other things that we see that's sometimes rare about iron deficiencies is summer-induced iron deficiency. And this happens when temperature stress goes up and iron almost looks like a chlorosis. We oftentimes see it on sandy soils. We add iron to combat the onset of the chlorosis. We also talk about manganese. Again, manganese is very active in a lot of the plant enzymes, helps with root growth, many positive functions in the plant. And we see these necessary in anywhere from 20 to 500 parts per million in tissue. Oftentimes when we do soil tests, they're misleading on how much manganese is needed. You can see a pretty wide range in soil tissue to be in the adequate range. And so that's, still more to be figured out about what manganese levels are really needed in turf grass and to what amounts. We also move on to zinc here. Again, this is, important membrane function, stress management, especially at high temperatures. When we look at tissues, 20 to 55 parts per million is going to tell us that we have enough tissue or content in the tissue. 15 to 20 parts per million is going to say that it's deficient there. If we look at a soil test, we've seen soil tests where we've actually seen some cool season grasses that have had soil tests of zinc levels from 18 to 20 parts per million, which has showed up to actually be toxic to the grass and hurting it there. So again, it's a very fine range we're walking. Again, I show that the values here as tissue levels, 18 to 20 parts per million in soil tests have shown to be toxic there for zinc. A couple other micronutrients to talk about here. We've got copper. Again, copper is very important in lignin formation, carbohydrate formation. And you can see it's required in smaller amounts in some of the other elements we've talked about. Deficiencies show up in high soil pHs. They're rare, but they do show up there. So if you have a high soil pH, you may need to be on the lookout for copper deficiencies. We also talk about boron here. Again, another micronutrient. Membrane and cell wall formations, very important for boron. 5 to 10 parts per million in the tissue. Deficiencies are rare. Again, boron, very rare range between being deficient and being toxic, and that can be problematic. Finally, our last microelement that we're going to talk about, or micronutrient, is molybdenum. Again, older leaves can turn pale green, and you can see just how small of amounts of parts per million is really necessary in the plant. So what we hope you can take from our seminar at the conference, and even from today, is these values that you need, and run a tissue test or a soil test against them, and then take those to those in charge of your budget, or as you're making your budget, and budget in to make sure that you have a balanced nutrition to keep your plant growth going. And that should help you improve plant growth. It should help with better conditions for growing on your athletic field as far as that goes. One of the things that we always like to do at the conference is we really like to see people bring their soil test to us, so we can actually kind of see what's going on and what's needed as far as that goes. And so we have no problem doing that at the conference. So bring that along, stop Nick or myself, and we'd love to look through those and talk about those. I guess at this point in time, I've kind of right at my 15-20 minute mark. And so I'll open it up to any questions. I don't see anything right now in the chat box, but I'll sit for a minute or two if anyone has any.
Just a reminder that if you have any questions, go ahead and enter them into the Q&A feature or the chat box. Doesn't look like we have any, so.
All right.
All right, well, thank you, Adam, and thank you all for joining us today. This presentation will be featured at STMA's annual conference, so make sure to come prepared with questions. We hope to see you all there. Thank you, everyone, and have a great rest of the week.
Thanks.